Section 5.6, we're going to be graphing other trigonometric functions, but we still need to use our sine, cosine, and tangent functions in order to graph the reciprocal functions. I'm going to graph cosine in order to help guide me with secant. So I need to identify what the amplitude is and what the period is of the cosine of this. The amplitude is the absolute value of the A value, and the A value here is 2, the B value is 4, the C value is 0, and the D value is 0. The amplitude is then 2, which means that my graph is vertically stretching by a value of 2. My period is 2 pi divided by 4, which is pi over 2. There's no phase shift. Remember, your phase shift is found by taking your C divided by B, and there is no vertical shift since we are not adding a D value. Cosine of x is equal to 0 normally when x equals pi over 2 and 3 pi over 2. The period has adjusted that by 1/4, and so at pi over 8 and 3 pi over 8 is when you're going to have zeros. So let's sketch out the cosine based on those maximums and minimums and our 0 values. We have values of 2 when x equals 0 and when x equals pi over 2, so one full period. And halfway in between that, we get our minimum value, -2, because of the vertical stretch. And I'm mirroring it on the other side since cosine is an even function. We need to cross from positives to negatives. Halfway in between then, 0 and pi over 4. At pi over 8, I'm going to cross through 0, and negative pi over 8, negative 3 pi over 8. And I can sketch this graph. This is 2 cycles. It's actually a little bit more curved than that, but you get the idea. Now, the reciprocal function is going to be undefined or have vertical asymptotes whenever the cosine of x is 0. So I can draw those asymptotes now. And remember that the secant just goes on top of or below the cosine function. What I've drawn there is one full period, and I had a little bit extra over here as I was duplicating, so I can just draw another piece of the graph if I would like to. So that is the graph of 2 secant 4x. Moving on, we're going to graph the function of cosecant x plus pi minus 2 for skill practice 2. Let's identify our parts A, B, C, and D to see if we have a phase shift or a vertical shift and what our period is and what our amplitude is. A is equal to 1 because there is no coefficient in front of cosecant, so we imagine that there's a 1 there. B is equal to 1. Negative pi because the sign inside with x should originally be negative, so when it's not negative, that means that the value of C is negative. And D is equal to -2. Graphing sine, what would the graph of sine look like first? The amplitude here is 1. The period is 2 pi because you have 2 pi over 1. The phase shift is negative pi over 1 or negative pi, and the vertical shift is negative d. So we have some information here, and we can also determine where one full interval is going to be by using the idea of 0 is less than or equal to bx minus c is less than or equal to 2 pi. Subtracting pi from all three sides of the inequality, we have negative pi is less than or equal to x is less than or equal to pi. So one full interval is going to happen from negative pi to pi. Graphing the sine, remember that sine starts at 0, 0. And so I'm going to do a vertical shift down 2. And I'm also going to do a phase shift negative pi, which means I'm going to the left pi. So that's going to go through the point negative pi, -2. Normally, the graph of sine goes through 2 pi at 0 as well. So I can shift that 1 pi to the left and down 2 for the vertical shift. So that's going to be our negative pi to pi full cycle. On that full cycle, I have an amplitude of 1, and so I do need to have my maximum value and my minimum values plotted as well. Sine crosses through the axis normally from 0 to 2 pi at pi. So from pi, I can go pi back and 2 down. That's normally where I would cross through the x-axis. Halfway between these points, I need to be obtaining my maximum and minimum values. Pi typically obtains its maximum first as the graph increases, then it goes through 0 and decreases. I'm going to have my maximum then at negative pi over 2 and negative 1, which is the same thing as if I had started at pi over 2, I do my phase shift back pi and down 2. And then my minimum value at pi over 2 is negative 3, which, if you remember, the minimum value of the regular sine function happens at negative 1 and 3 pi over 2. So if I phase shift back pi and down 2, I get that minimum value. Now, anywhere that sine is 0 in the original function, my cosecant graph is going to have an asymptote because I can't divide by 0 in that reciprocal function. So I'm going to draw those asymptotes now. I can connect my sine graph. This is one full cycle of the graph of sine x plus pi minus 2. And then the cosecant function just sits on top of the sine function, which I will sketch now. And this is the graph of the cosecant of x plus pi minus 2.